Okay, so at the where we ended, I'm going to recap. We had started with the Limacons. Now, the cardioid is going to be considered a Limacon because it's still in that same form. We'll see related. So the cardioid we ended up with, because of the sign of theta, we had y-axis symmetry. I need to start waiting for that. So intercepts we found out were 0 and 6. So how do we get 6? By plugging 90 on the y-axis, angles on the y-axis, 90, 270. So we plug in 90, we get 6, 270 with 0. And the non-axis symmetrical axis, that of course was when on the x-axis we really have 3 0 degrees, 3 180 degrees. That's always the fallback position. Plug in the, and then we draw that again with the cardioid. We got that sharp in point inside. We saw example 2 was an inner loop Limason. When we saw, and then x-axis symmetry because of the cosine. So again, what angles are on the x-axis? 0, 180. So plugging in 0, we get -2, 180, 6. And again, if we wanted to fall back, the non-symmetrical is the y-axis. So that would be plugging in 90. We would get 2. Plugging in 270, we would get 2 again. In other words, the a value. Why? Because the cosine on the y-axis is 0. So 4 times 0 is boring. Alrighty, and then we, of course, the crossover, this link, this overlap, or I call it the crossover, because we go from a negative to a positive r. So when we draw it, start with negative r's, and then to get to the positive, we have to go through 0. And then back to complete that rotation of angles around, we again have to cross over 0. So that's where that crossover is at the pole. Okay, what about this one here? So if I take a, don't want to look at that. Okay, so this one is a little different. Notice how the A and B's are different. This is a dimpled Limason. So it's going to act the same way with y-axis because of the sign, y-axis symmetry because of the sign. So we still plug in 90 and 270. So sine of 90 is 1. 4 plus 2 times 1. Plug in 270. Sine of 270 is -1. 4 plus 2 times -1. So 272. Now, non-symmetrical axis, again, this time, what's the sign on the y-axis? Well, the sign on the y-axis is 0. So we had 4 times 2 times 0, or just 4. So that's how we could tell that the non-symmetrical axis is just going to be that a value. Now, how does this look? Well, of course, this side away, oops, that was bad. The side that goes the furthest away from the pole, from the origin, looks more like a circle. Now this dimple, there's nothing, no sharp indentation. It's just a slight dimple or slight dent in it. So just a little slight dent in that. Nothing sharp. The sharp corners, the sharp point is for the cardioid. Okay, so there's your three different kinds that have very similar, very much like equations. So let's take a look at, see how we could sort those out. So before we do that, one thing we want to touch base with, again, when our equation has sine in it, that means we have our y-axis symmetry. And when your equation has cosine, that's your x-axis symmetry. And your non-symmetrical intercepts is just A. Actually, we'll say absolute value A because we really don't care if it's positive or negative. We're going to go both directions anyways. So the cardioid, example 1, we found out that the A and the B were the same. Now, in terms of doing this, we really don't care if it's positive or negative for that. We just want to make sure that the absolute values are the same. The dimpled limacone and the inner loop limacone, well, of course, those are different. Okay, so how did the A compare to the B in the dimpled? That was example 3. And how did the A compare to B in the inner loop? Example 2. So in example 2, again, not worried about negative. A is 2, B is 4. Where the dimple limacone, A was 4, B is 2. So here, the dimple limacone, A is greater, and the inner loop, B is bigger. So that to get the inner loop, the inside's bigger. Okay? So I'm going to let you go ahead and let's walk a little bit more time to go through this one. So let's go ahead and work with this. What is this? You know, it's not a cardioid because they're different. So is the A, the absolute value, bigger or smaller than the B? So it's a dimpled. If I could spell it would be good. Limacone. Symmetry, which trig function? That really refers to? And so what are the intercepts then on the x-axis? Cosine is 0, so -3 plus 2 times 1. -3 plus, now at 180, cosine of 180 is. So -3 plus 2 times -1. Plot those 2 points. Now the intercepts, now you say, wait a minute, shouldn't that be -3? Well, it is, because again, on the y-axis, the cosine is 0, so 2 times 0 is boring, especially when you add through -3. But if we would actually try, see what happens when we plug in 90. So the cosine is 0, or cosine of 90, sorry, is 0. So -3 plus 2 times 0 is -3. Well, that is down here. And then if we would do the same thing for 270, we would end up here. Doesn't look any different than we would have it if it was positive or negative. So it's not going to make a difference. Now, see, when I was in school, we didn't have the just connect whatever. We actually plugged in a whole bunch of points, and we realized that this dimpled limacone would be drawn like that again. Not very nicely, but away from the origin, the furthest one away looks like that big circle. And then here's the little dimple, smooth dimple. Okay? I'm going to let you do number 5 on your own. You can look on the wiki and the finished product for the answer for that.